All right, section 10.5, we are looking at tangent and secant segments. So a tangent segment is a segment that is tangent to a circle at an endpoint. So instead of being a line, it's just a segment that is tangent to it. So in this picture, it would be segment PS, it would be a tangent segment. A secant segment is a segment that is secant to a circle, which would be segment PR, right, hitting in the circle in two places. But it does go outside the circle, because remember, if it didn't go outside the circle and it just hits it in two places, then it's just a chord, not a secant. All right, so then we can also have what we call the external secant segment, which is the portion of a secant segment that is outside the circle. So we got PR is a secant segment, PQ is the external secant segment, or the part of that secant segment that's outside the circle. Theorem 10.5, if two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the other chord. All right, so I've got these two chords intersecting inside the circle. If I take the lengths of the two parts times each other, for each one of them, they should be equal. So segment EA, the length of that, times EB is going to be equal to EC times ED. Right, so where they intersect and break each other into two parts, when you multiply the two parts together, they should be equal to each other. All right, theorem 10.16. If two secant segments share the same endpoint outside the circle, then the product of the length of one secant segment and the length of its external segment equals the product of the length of the other secant segment and the length of its external segment. So two secant segments, they intersect outside the circle. So the external secant segment times the entire secant segment is going to equal the external segment times the entire segment for the other secant. Right, so kind of similar to theorem 10.15 with the chords, it's just secants this time. So the two parts, or the outside part times the whole thing, should equal the outside part times the whole thing. And theorem 10.17, if a secant segment and a tangent segment share an endpoint outside a circle, then the product of the length of the secant segment and the length of its external segment equals the square of the length of the tangent segment. So in this one, it's the same rule with the secant. You take the outside part times the whole thing, and that's going to be equal to the length of the tangent segment squared. All right, so I'm going to find the value of x here. We have two chords intersecting. So the rule is that if I multiply the two parts together of one chord, that should equal the product of the two parts of the other chord multiplied together. So we got x times 18 should equal 12 times 9. That'll give us 18x equals 108. If we divide by the 18 to solve for x, our x value will be 6 there. Alright, so the B portion, we got two secant segments in this case. So with secant segments, it's the external part times the whole thing equals the external part times the whole thing. So for the whole thing, we have 10 plus 11, which is 21 there. And on this one, it'll just be 12 plus x. So to set it up, the external portion of FD, which is ED, will be 11 times the whole thing, which is 21. And that's going to be equal to the external segment DG, which is 12, times the whole segment, which is 12 plus x. And we have 11 times 21, which is 231. And distribute that 12, give us 144 plus 12x. Subtract the 144 from both sides. 87 equals 12x. And divide by 12. That's 7.25 equals x. So then C here, we got a tangent segment, which is AB, times the secant segment AD. So in this situation, the outside part of the secant segment times the whole thing is supposed to equal the tangent segment squared. So we have 24 plus x for the whole length of that secant segment. So we're going to have the outside portion, 24, times the whole thing, 24 plus x, is going to equal the tangent segment squared, 30 squared. So distribute the 24, 576 plus 24x is going to equal 900. And then just solve for x. So subtract 576. It's 24x equals 324. And divide by the 24. Give us x equals 13.5. Alright, so then this next one, we've got the entire secant segment given to us as X. Outside secant segment is 14. Then we've got a tangent segment that's 22. So for the secant segment, it's the external secant segment, or the outside part, times the whole thing, which is just X. It's going to equal the tangent segment squared. So 14x equals 484. Divided by 14. X equals 34.57. And that one's rounded. So that concludes notes. Anybody have any questions?